just wanted to briefly mention IAVCEI. So as a commission, the Tephra Hazard Modeling Commission, we will aim to organize a social. It's not organized yet because we're waiting for the scientific assembly to be finalized. But if you want to be aware of any social plan, please subscribe to our mailing list, because that would be the main way we communicate about it. So you can just scan the QR code there. It's also on our website. And yeah, so the IAVCEI Scientific Assembly obviously is in Geneva, June 29 to July 4. So we hope to see many of you there. And just a reminder, the early bird registration deadline is a month from now. And we have a really exciting IAVCEI, I think, from a Tephra perspective. So there are many sessions, and most people registered for this seminar. I've seen the name on submission, so most of you are aware. But also don't forget about the workshop. There are at least 4 different workshops that are either sponsored by our commissions or directly relevant. So there's one on grain size, analysis of volcanic ash. There's one on connecting operational response and research. There's one on volcanic plume benchmarking exercise, integrating field modeling and analog experiment. And there is one that we don't sponsor, but that's very much relevant to us, which is field collection of Tephra data. That's just the one that are directly relevant. It's actually very rich in workshops. There's, for example, one on satellite data for volcano, early career empowerment, inclusive collaboration, and so on. So just don't forget to check this out when you register. And yeah, we look forward to seeing you there. It should be a really, really exciting scientific assembly. And so just a welcome again to our Ashvances Seminar Series. So we have this quarterly seminar. We aim to do one online every 3 months. So each speaker, we have 2 speakers per seminar. Each of them give a 15-20 minute talk, followed by 5 to 10 minutes of questions. And then at the end, we aim to have any discussion of the talk just given or wider commission activity. We regularly rotate time zone between more Atlantic and Pacific friendly time. So if you're here, you're most likely not too far from the Atlantic. Although I guess Edwin today is about as close to the Atlantic and the Pacific. Yeah, and we particularly aim to showcase research from early career and underrepresented group. If you want to register your interest to give a talk, or so self-nominate yourself or nominate a colleague, we have a form for that. So please, by all means, do that. We're always looking for speakers, and we should have one more seminar before the IAVCEI assembly. So without further ado, 2 speakers today. So our first talk will be given by Silvia Massaro from the University of Bari and the INGV Bologna. We talk about probabilistic hazard assessment with an example for Neapolitan volcanoes. And our second speaker is Edwin Telenchana from the Instituto Geofísico of the Escuela Politécnica Nacional, Ecuador. And here we talk about eruption record in the northern Andes during the Holocene. So I will stop sharing, and Silvia, you can unmute yourself and share your screen, and the floor is yours. I can unmute yourself. Hold on. I thought I could unmute you, but I can't. So you're currently muted. Are you able to? Yeah, that's better. Thanks.
Okay, so now it's work. Perfect.
Yes, I can't see your camera anymore.
Okay, the important thing is that you see the screen. In this way, you see the screen.
It's very small for me, but I don't know about other people.
I'm doing the full screen on my laptop.
Okay.
So
I try again.
So let me know. I'm sharing the full screen right now.
You're not sharing at the moment.
Okay, let me try again. Let me try again the sharing. No, this. You see now?
It's coming up. Yes, that's better.
And the full screen now?
Yes,
Yes.
perfect.
Okay, perfect.
Thank you.
So we can. You're welcome. So, good afternoon to all. I'm very happy to have this talk today about a study that I finished 2 years ago, but on which I'm still working on, because the topic of the long-term hazard assessment is very challenging. So, in this last year. So now I'm going to show you the example from the Napolitan volcanoes in the southern Italy. So as I said, this work was born into 2023, and it's essentially based on two important papers that was issued in the 2022 regarding the temporal evolution of eruptive activity in the hazard estimation, and on the feasibility on APCC resources in doing the probabilistic volcanic hazard assessment in the Napolitan area in the south of Italy. Actually, as we all know, the volcanoes show intrinsically multi-hazard and risk activities, and this imply the interaction with the different eruptive events which impacting the environment and the society. As all we know, the most frequent and widespread is the fallout of tephra that occurs in more than 90% of all eruption over the world. And in this regard, I'm going to show you a brief introduction to show you some information on the modeling of dispersion of the fallout in the atmosphere. That when occur on the ground, they can do damage on crops, on the water resources, on infrastructure, as for example the supply lines, and of course on the human health. On a larger scale, as in the as in the case of some past eruption, you can see that the fine ash reach the stratosphere and do some interaction with the solar rays that in turn can impact on the climate all over the world. In the last years, the scientific community has done numerous codes for the simulation of this tephra fallout in the atmosphere, based on the wind data, on the shape of the particles, on the height of the columns, on eruption rates, and they do this in 1D, 2D, and even in 3D case. With the help of the clusters, so with the help of high performing resources. These codes are used every day in this period for operational ORECAs and for hazard assessment studies. In this table, I can show you a summary with all information about the families of these codes that are a lot of codes that are used for the daily activities by the 9 ASH advisory centers in the world. Some of these are also free, like for 3D code. Above all, it's very important to stress in this seminar, in this talk, that in all models we have always as this part. The first one is the meteorological model to describe the state of the atmosphere for the regional and for the local scales in two options, like for the forecast and for the reanalysis options. The second part is the emission model to define the source in time and space, in this case the plume of the volcanic eruption, and the last part is the dispersion model, which account for the physics of the process. In this part, you can have the simulation of the abduction of the wind, chemical reaction between the species, so with tephra and also with gases, the aggregation of the particles, the turbulence of the atmosphere, and so on. So it's important to stress that for each part you have uncertainty in the components, either in the physics of the model or in the inputs. But the most challenging is the emission model, of course. So let's move to the research question of this study. How we can quantify a volcanic hazard, and how in case of the fallout of tephra, and what could happen in the next years in case of new eruptive activities from the Neapolitan volcanoes. So first of all, we need to recall a very important idea regarding the approach to estimate the volcanic hazard, which is not possible to express like a symbol, a single number. So you all know that volcanoes behave randomly, and for this reason we need to face with the statistical approach to study the probability of occurrence of the eruptions and their intrinsic nature, of course. So in this work we used the modeling to capture the uncertainty, analyzing a large set of output which account for the variability of the input set of data that you use. So the forecast of the type and the size of the next eruption from a given volcano can be also achieved only accounting for the main uncertainty on the source and in general on the wind data. So for this reason, an approach that is robust is given by the PET models, which are largely used to calculate the probability of any kind of short and long-term hazard by simulating all the volcanological information in function, allowing that aleatoric and epistemic uncertainty is accounted for. The probabilistic hazard assessment is often done for a single event, so for a single volcano, but in other fields like for the tsunami or for the seismology, the hazard is computed integrating all over the sources. In our field, actually, this is very hard to do, since the volcanic system maybe have the different phases of activity, and this could be hard to get an homogeneous integration of sources in a single hazard study. Another issue that is very tricky is the size of the eruption. The historical approach used in the last decades has been done to the occurrence of a single eruption, or due to a group of events. In this way, actually, the comparison with system having some kind of different event was impossible. So the first application that we did at the Neapolitan area for the yellow zone, as you can see in this picture, can be found in studies like those of Silvia et al. Of 2020 that you can see in this picture. In this study, they account for the uncertainty of the winds and also of the vents. So these two aspects were catch the epistemic uncertainty to get unbiased hazard estimation. Well, in this regard, we have done this new study to get and to have a long-term hazard assessment of the fallout of Tephra by the three active volcano in Napolitan area. So Vesuvio, Ischia, and Campi Flegrei. In the southern Italy, as you see, as you actually know, these sources are explosive with a very high exposure, since more than 3 million of people live in this red area that you can see on the picture. So. Like for the tsunami case and for the earthquakes, these the strategy that we get should to add the contribution of the sources. So these three volcano to get the mean annual rate of a specific density threshold, that is in this case is the load of the Tephra on the ground, at a point on our domain in a time windows that we set for 50 years, so for the next step of years. So by this formula, actually for each point of the domain, we get the mean rate, so that is lambda, of overcoming a event threshold for the source, for the vents, and for the size. And we do this by multiplying the annual rate of the eruption, the probability of size class, and also for the vent, to overcome this number, this load on the ground. So this last data will be then given by doing a very large number of runs of dispersion of the Tephra in the atmosphere with the fault 3D code. So first of all, we set the eruptive scenarios for each volcano in order to have a synthetic block of data of the loads at ground by doing more than 10 thousand of runs with the full 3D code. So we set a small, a medium, and a large size for both for Vesuvius and Campi Flegrei, and a one large size class for Ischia. Our domain is the south of Italy with a special horizontal resolution of 3 kilometers. So for each source and for each size, we took the estimation of the mean annual rate of occurrence of an eruption for the given window of 50 years by the study of Selva et al. Then we randomly sampled the inputs data that we need for the model, such as the mass, the duration of the eruption, the ground size distribution, and of course the winds condition over the last 30 years. Well, the hazard was done with the new version of the BERT workflow that was adopted by the work of Beatrice Martinez in 2022 for the Campi Flegrei. Within the script, we add the information of the mean annual rate of each source, the vent, the size of the sources, and then we put inside this script the set of the simulation that we get with the full 3D to know if this load overcome a fixed set of 16 threshold that we set from 0.01 to 16 kilopascal for each point of the domain. Finally, the workflow is able to plot the maps that we did inside the script for the single source, and also accounting for the overall combination of their impacts. Actually, after we have also analyzed the single contribution of the size of each source to the hazard by doing a disaggregation of the loads of Tephra that we have on the maps, and we did this only for the Vesuvius and for the Flegrei. We don't do this for the Ischia case because we have only one size for Ischia. In this slide, I show you the long-term hazard map for single source obtained by cutting the curves in each point of the domain. We say in general that the likely loads occur frequently, so you can say that this load can be associated to a shorted average repose time, which is the inverse of the mean annual rate actually in the formula. In this case, we get a mean annual rate that is equal of 500 years of average repose time. And what we see in these plots is that the loads, the high load are near the bands, and that actually the Somma Vesuvio is the source with the larger area of fallout that is covering almost the entire area of our domain. And this is important because this source is the most active actually. In general, is the most active. In this slide, you can see the maps with the aggregation of the results at 3 annual rate. So for 100, 500, and 1,000 years of average repose time. In this case, you can see that at IG, so at 1,000 year, you see a larger area of loads, and you can have also IG loads with respect to the other one. And this is due to the fact that these events are actually rare, since you are doing a very large time of repose. Also, it's important to note that the effect of the fringed edge that you can see on the area at the boundary of the domain are due to artifacts of the simulations, since a low number of runs is reaching that point that are far from the source.
Silvia?
Yeah.
Yeah, if you manage to conclude within 2 or 3 minutes, I think that would be good for to have a bit of discussion time. Just a heads up.
Yes, I finished.
Thank you.
So we can go over and going to this plot actually that is more important actually, the final picture. In this case, you see that with the green you see the size of one source, that is Somma. In red you see for the Ampiflegrei, and the blue for Ischia. So we set a threshold that is fixed at 10 kilogram per square meters, and the summary is this: that actually the Somma Vesuvio is the source that is more active, and you can see that here their sides are in the entire part of the domain, and for the other two, you can see that their impact is only near the vent, near their vent. So finally, I would like to give some take-home messages for this short talk. And we actually do a new approach to do a long-term hazard assessment in the southern Italy for the combination of 3 sources. The output of our model were being used in a new BET workflow for large-scale high resolution hazard assessment to get the annual frequency in the next Windows time of 15 years, and also we can do this application in area in which you have I mean some sources that are active, and they can impact the people that live there. So it's a new tool that I hope to apply in other area of the world, because it's powerful. I mean, it works for this area in the southern Italy. Finished. Thank you.
Thanks a lot, Silvia.
Okay, thanks, you too.
Do we have any question? And you can either write them in the chat and I can ask them, or you can raise your hand. Yeah, Johan, go ahead, please.
Hi, John.
Hi. Silvia, thanks for the nice presentation. Apologies, I rolled out of bed to make your talk, I'll be honest. So very nice results. I'm interested in how the Ash 3D modeling, uh, for example, how you do a parameter, a set of parameters to run the model to create all the different simulations of Ash transport. In particular, is part of the workflow to inject ash at various heights and run the simulations for the same source conditions to see how injection height in the atmosphere changes the results?
Okay, I use this code that is free, so it's for 3D, and we change a lot the inputs. So we have um, a function to sample within some ranges all the inputs. So we have varied the column height, we have varied the mass, we have varied the wind condition over the last 30 years. We have varied also the time of the eruptions. So actually, we vary all the inputs that you have in the model, and to get, an unbiased hazard study. Actually,
Okay, thank you.
you're welcome. And I see on the chat another question.
So I think there was a bit of Ash 3D chat on the chat. So yeah, it might be an Ash 3D question, not a full 3D one.
Okay, not.
Is there any other question on Silvia's talk? I had a quick one in the meantime, which is so the hazard map is for 50 years into the future, so to 2075. But the atmospheric condition used are 1990 to 2020. Yeah, I'm just wondering if you thought about using different atmospheric condition, and how big of a source of uncertainty do you think it is?
So this is a tricky point because the wind condition have a larger, coarse resolution. So you have to think that we use the set of the ERA 5, that it has a coarse resolution of 40 kilometers, and actually if you change the wind condition and you use some drivers like WRF, the impact of the wind on the simulation should be large, of course. So the wind condition impose on your simulation a kind of uncertainty that is large. So if you change the driver and change higher resolution for the wind condition, I expect to have hazard maps that are finer, that are better.
I was thinking about how climate change could affect that, but yeah, I guess there are even bigger source of uncertainty, like what's the present day source of meteorology you use. Larry has a question, and I suggest we make this the last one and try to keep it concise for the sake of time, because we should move to Edwin's talk. So go ahead, Larry.
Thank you. Thank you, Silvia, for that interesting talk.
Many thanks.
One thing I've noticed, I've done a lot of probabilistic Tephra simulations using Ash 3D, and what I've found in speaking to, say, the academic community is they're much more interested in these probabilistic results than local civil defense officials. And I was wondering if you've talked to local civil defense people about what kinds of outputs would be of greatest interest to them.
Yes. Okay. Actually, we didn't talk at the time of my study with office, but in the future we are going to do it because they are creating new maps for the hazard in the area, of course, by the fallout of Tephra. And these results, the problem is that they are quite scared about new maps. And every time that we try
Yeah.
to say that this is a statistical approach and not a single scenario, so they found difficulties in understanding the wide range of sites that you can have in the future. So they want a single scenario. They want a single scenario, and they want a single maps that is able to explain a future scenario for the eruption. And this is tricky because they don't still accept the fact that we need to make a statistic and not a single scenario.
That's interesting.
Yes.
That's essentially the same thing I found with civil defense people in the US. They want a scenario that they can run an exercise with.
Yes.
So yeah, it's interesting. Thank you.
You're welcome, Larry.
Thanks again, Silvia. Yeah, and so we're moving on to Edwin's talk. I would just let you share screen, and floor is yours.
Yeah, is it okay? You can see my screen, full screen?
Yes, yeah, it's showing fine.
Thank you so much. Hello, everyone. I am going to talk about the record of evolution occurred in the northern Andes during the Holocene. My topic is more associated with thermochronology and the analysis of the laboratory. So, sorry. Yeah. About the content, I want to talk about the brief introduction, volcanic record in the pet box, and the component analyze, and the conclusion. Yep. So the continental volcanic area in Ecuador is composed of the less 80 quaternary volcanic centers, of which at least 20 have experienced confirmed eruptive episodes during the Holocene. Yep. The Chile's Cerro Negro volcanic complex is located on the border between the Ecuador and Colombia. Yeah. This is Chile's volcano, and it is Cerro Negro volcano. Yeah. Is located 120 kilometers north of the Quito, and 25 kilometers west to the Tulcán city in the province of the Carchi. The red star represents the Potrerello zone. About the Chile's and Cerro Negro volcanoes, yeah, Chile's has 4,748 meters at sea level, and the Cerro Negro has 4,460 meters at sea level, each one with 5 and 6 diameter kilometers. Both are stratovolcanoes in the volcanic complex. Both are landslide scarce with a diameter of 1 kilometer. For example, in this part you can see the landslide scare of Cerro Negro volcano. Yeah, both consists of lava flows principally. The last eruption, there are no acquired historical records of eruptive activity, and the recently activity is characteristic for hydrothermal and seismic activity. About the monitoring, Geofísico Institute made seismic and deformation control and the fluids. So about the justification for this study, several seismic swarms have occurred in the Chile Cerro Negro area, yeah, since 2013. In this area, earthquakes with magnitudes exceeding 5 were recorded in 2014 and 2022, causing damage to homes and infrastructure near the epicenters. Additionally, efforts are being made to determine whether these volcanoes can be considered potentially active. The lack of information about the eruptive historic of the volcanoes further underscore the need for detailed studies. This highlights the importance of conducting volcanic research in the Chile Cerro Negro area to improve the understanding of its evolution over time and its current behavior. For this reason, efforts have begun to establish an eruption record in the area by analysis tephra deposition preserved in the pit box. So about the volcanic record in pit box, what are the pit box? Pit box wetland where organic matter has accumulated in front of the pit. Why did we select this site for drilling? Because it's an area with continuous sediment deposition, minimal tectonic disturbance, accumulation of organic material and volcanic ash, and no anthropogenic impact. So for the methodology, the um, the drilling was the drill core was obtained from the Potrerillos pit bot in this zone. Is located west southeast of Cerro Negro volcano. For this case, we use a manual metal drill, yeah, which with a 1 meter core sample was used, yeah. During drilling, continuous deep control was required using a tape measure, which also allowed for an initial identification of the different tephra layers based on their color and essence. For example, in this picture, you can see brown color corresponds to the pit layers, and the gray colors represents a different ash layer, gray or white color. For example, this part. Um, in the field description was conducted documenting the color and size and the main microscopic components. So continues with the methodology. The drill core was grouped in aluminum foil and placed inside a PVC tube, which was then covered with plastic film for transportation to prevent any external contaminants from affecting the pit box component. So in the laboratory, the drill core was dried in an oven at 40 degrees Celsius. During the drill process, continuous weight monitoring was conducted until the samples were completely dried. Additionally, longitudinal and measurement before and after drying. So at the end of this process, the drill cores were examined in detail to sample collection the ash layers and the pit layers overlying and underlying the ash layers for their respective analysis. So in this part, we classificate the different layers from A to AB, classified to different layers with this nomenclature. So about the results, the tephra the drill core reached a deep 5 meters, yeah, all on depth, and it was possible to identify 1, 2, 3, and 12 ash layer with within the core. The 12 identifier as layer, yeah, have a thickness ranging from 0.5 centimeters to 14.5 centimeters, such as the layer P in this part. 9 pit samples were collected from underlying A, D, G, K, N, and another were collected from underlying to select Tephra layers for radiocarbon dating. Yep. 9 radiocarbon dating age were obtained from organic sediments found underlying the major layers, showing an age range from 200 to around 6,000 years before the present. In the drill core, the layers of ash has medium to extremely fine-grained volcanic ash were identified. So about the lithological analysis, this analysis was performed using binocular microscope. Yep. The class that make up the volcanic ash were classified using textural criteria according to the classification by McPhee et al. 1993 or Etienne and Lepeneg 2012. And it was possible to classify of components in 5 groups: pumice, scoria, lithics, oxidized particles, and crystal. In this picture, in this sample, you can see different components. For example, pyroxenes, pumice, organic matter, biotite, and plagioclase. Yeah. So about the lithological composition, due to their small thickness and associated sample among layer A and layer double A could not be analyzed in detail. The components analyzed of each as layer revealed the predominance of pumice and free crystal. Pumice in the purple color and the crystal in the orange color. Crystals such as plagioclase, amphibole, biotite, pyroxene, and quartz. So you can see the major of the samples present this tendency. So two sequences are clearly observed based of the nature of the minerals present. One sequence rich in plagioclase and amphibole and pyroxene correspond to magmas of intermediate composition. For example, A, C, F, A, G. Yep. And the second sequence, which is rich in plagioclase, biotite, and amphibole, and quartz, corresponds to typical mineral association with acid magmas, such as ash P, B, double B. Yep. So about with all of this, we made a correlation with the volcanic record. Yep. In this, it is important to remember that most the age obtained correspond to the pit samples underlying to the Tephra fault deposit, which means they will be considered as a minion age. Consequently, or subsequently, the physical characteristic of deposit and their components from other volcanoes were compared to determine whether there is a recognized and well-studied erosion that matches the found deposit. So, there are too many volcanoes in Ecuador and Colombia, yeah, that had erosion during periods close to the age obtained in this study. To reduce the number of candidates, the distance between the potential source and the Potrerillos pitfall was considered, as well as the size of the eruption using the Tephra volume correspond the after limit of the volcanic explosive index assigned in the database. So, for example, another thing is in basis to the grain size, which is predominantly small, with no uh, lapilli size grain observed. This suggests not local sources. They will not belong the volcanic complex. Yep. So, for example, we have eruptions associated with different volcanoes, for example, Cotopaxi, Guagua Pichincha, Atacazo Ninahuilca or Ninahuilca, Pululagua. For the Colombian part, we have Azufral de Túquerres, Doña Juana, and other volcanoes with Chachimbiro or anymore. Yeah. So two groups of ash were identified. A group of intermediated to acid ashes, probably related to the Ecuadorian volcanic front, Western Cordillera. In this group, we identified a layer possibility related to the 10th century Guagua Pichincha's eruption. And the second group in the bottom part of the pitbox, a group of acid ashes probably erupted from the Azufral volcano, Azufral de Túquerres, in Colombia, corresponding to an explosive activity that took place between 2000 2800 to 4800 just before the press. So the conclusion, we have the radiometric carbon age provides a basis for comparing the ice layers with the eruptive events near the Potrerillo zone. The only well-defined layer would correspond to the eruption of the Guagua Pichincha volcano in the 10th century. The 10th century is the ash sea. The active of a Sufral volcano is likely the source of the ash layer dated between 1800 to 4800 years before the present. Layers are characterized by a high proportion of pumice and plagioclase crystal in similar amounts. As the main result to the identified as layer don't belongs the Chile Cerro Negro volcanic complex, suggests that no explosive activity occurring in this complex during the analyzed period. Consequently, no proximal deposit associated with explosive events were found, such as surges or pyroclastic flows. the lapilli size grains were identified. This suggests no local source. The ash layer are almost homogeneous with no appreciated variation in the thickness. So another conclusion, Paramo pitbogs are highly favorably cities for the recording and preservation of ash layer. Therefore, it's important to continue with additional drilling to obtain a more complete record. The analysis of lithological components reveal a higher presence of pumice, plagioclase crystal, and biotite, and in the analysis ash layer, this could be associated with intermediate to acid volcanics characteristic of the volcanic from Western Cordillera in Ecuador. And the proportion of different components in the ash layers could help distinguish between possible sources. However, the selected disposition of components due their density must be considered. Thank you for your attention.
Thanks a lot, Edwin. Is there any question for Edwin? And again, you can just raise your hand or ask in the chat. Yeah, Johan, go ahead.
Hi, Edwin. Thanks for the nice work here to characterize the activity from the peat bogs. It's a very nice method. I'm just curious, I know it's hard to do this in such thin layers, but were you able to observe any changes in grain size characteristics vertically in any of these layers? And then also, was there any evidence for small lithic particles in the ash layers as well?
Yeah, no, really no observed variations in the ash layer. It's very continuous, is very fine the grain. So no observed in the variation in the ash layer.
Thanks.
And I will ask one in the meantime. Is there, and also to make the link to Silvia's talk, is there any scope to use your pit bog data to inform hazard assessment? I guess in particular, you can be constrain recurrence rate of Tephra fallout or explosive eruption, but maybe also something about size. And would you need more pit bog data to do that?
Yes, I think that it's more. I need to make more pit bogs in the area. For example, the Chiles and Cerro Negro volcanic complex. There are pit bogs around of the volcanoes. It's possible to make another drillings for to discriminate all this study. I have we have two drilling core, two pit samples, but the second drill core is no good preservation. We have one problem, so I need two more drilling.
Thank you. Any other question for Edwin? Yeah, go ahead, Larry.
Thank you, Edwin. So this may be a question for you or anybody else, but I've been working with some people in, for example, Jill Plunkett at Belfast, who's been looking at cryptotephras in peat bogs in Ireland. And the interesting thing that she's found is that there are some tephras that she's found, for example, Mount St. Helens ash in peat bogs in Ireland, and tephras from Alaskan and even Kamchatkan volcanoes. And it makes me wonder whether there is actually a global database of geochemical data out there that can be compared if you might be looking for a tephra from a more distant volcano. It seems like I'm not really familiar with the cryptotephra studies enough to know whether anybody's compiling a global database of geochemical data that can be used to identify sources of cryptotephras.
Yeah,
Yes.
I'm
Yes,
also
I
not
think it's a
sure.
good idea.
Sorry.
Yeah.
Go ahead,
Yeah,
Edwin.
I think it's a good idea to compare the geochemical as a layer with another database. For example, in my study, I don't have a geochemical analysis for the ice layers. It's 1 point less for me. Sorry, but I think that it's a good idea to compare with another database and the other and another information with geochemicals, for example.
Okay, thank you. I'm conscious we are a bit over time, so maybe we can all thank our two speakers again. Thank you, Silvia, and thank you, Edwin, for giving talks today.
You're welcome, Thomas, and thanks to
You're
all for the
welcome.
time.
Thank you so much.